In this video, we are going to see about hunting of synchronous machine or synchronous motor. Okay, the hunting also we call it as a surging or a phase swing. So when a synchronous motor is used for varying loads, it's like if it is a driving a varying load, then the condition we call it as a hunting is taking place. Okay, the causes may be lot. We will discuss about the cause later. Okay, usually the frequency supply frequency is pulsating, then obviously the hunting effect also take place. Okay, when we know that the synchronous motor is loaded. Okay, so if the synchronous motor is loaded for like a application like punch press, shears, compressions, or maybe the pumps. Okay, its rotor falls back in phase by the coupling angle alpha. Okay, we'll see alpha now. You can see the mechanical power developed. The mechanical power developed Pm equal to EBV ZS into cos theta minus alpha minus EB square by ZS cos alpha. And similarly, I can express in terms of cos alpha also the mechanical power equal to EBV divided by Z square Ra cos alpha plus Xs sin alpha minus EB Ra divided by Z square. And the torque also can be known as 9.55 into mechanical power divided by ns. If you notice here, the alpha here is nothing but a load angle and the theta is nothing but an internal angle. So the theta is nothing but an internal angle. So when it is connected with the load, the rotor falls back in phase with by the coupling angle alpha. Okay, so as the load increases, the angle also increases. So it produces more torque because the power is increasing, the torque also increasing. For the more torque is needed. Okay, so if now the sudden decrease in the motor load, for example, if the motor load is decreasing, okay, the motor immediately pull up or advance to the new value of alpha. So the load angle is changing to corresponding new load. Okay, but this process, the rotor overshoots. In this case, the rotor overshoots and is pulled back again. Okay, in this way the rotor starts oscillating. So it's like how the pendulum is oscillating. It's searching for the new position. Hunting is nothing but searching for a new place. Okay, so searching for a new equilibrium state. So if the time period of an oscillation happens to be equal, that is equal to natural time period of a machine, then the mechanical resonance is set up. That means the mechanical resonance closed now. So the amplitude of these oscillation is large value, then it's become great. So the machine out of synchronization. Okay, so the machine totally out of synchronization. To stop this, we have to go for the damper winding circuits. We call it as squirrel gauge winding, that we are going to discuss later. Okay, now this is the hunting. And what are the effects of hunting? You can see it may lead to lose the synchronization, because as I told, it's searching for the new portion. uh, the it may lose the synchronization because the synchronous motors runs in the synchronous manner, so that it's going to lose the synchronization, and it produces mechanical stress in the rotor shaft because it's a pulsating. So the most stresses will be on the rotor shaft, and it increases the machine losses, and also again it's going to increase the temperature. Okay, so because the oscillation causes surges in the current as well as the power flow, it is not only in the machine, that also the equipment connected along with that. Okay, it increases the possibility of resonance, so it out of the synchronism. Okay, and what are the causes of hunting? It's like the sudden change in load. As I told earlier, the sudden change in load, maybe the supply frequency, if it is a pulsating, then that is also possible. And sudden change in the field current, if the exciting current is changed, then also the chances are there. And if the torque is harmonic, it contains harmonic torque, then again the chances are there. fault in supply systems. So in case of fault, supply system is gets fault, then also hunting will happen at the uh, synchronous motors. Now I can reduce the hunting. So the reduction of hunting in synchronous machine or synchronous motor, we can go for the uh, damper winding. So as I told, the damper winding will reduce the hunting effect, and also we can go for the flywheels. And so if we designing the synchronous machine with suitable synchronizing power coefficient, then the hunting will not take place. Okay, these are the three possible way of reducing the reduction of the hunting. Mainly the damper winding, that is enough. So because if it is already embedded in the rotor winding, so that the damper winding will reduce the hunting in the synchronous machine. Okay, thank you.